Hey, so welcome to 9.1. This is going to be the only section for 9.1. This is going to be composition of functions. What we're doing today is an extension of inverse of functions, which we did earlier this semester, where instead of adding two functions together or finding where we swap the x and the y, what we're doing is we're plugging a function inside of another function. We're not adding them, we're not subtracting them, we're not multiplying or dividing them. We're taking what one function is, like let's say an x plus 2, we're plugging inside another function, let's say an x plus 3, plug that into that variable, and that is composing a brand new function. So let's go ahead and let's take a look. So let's look at today's section, which is composition of functions. And this is an extension of the inverse functions chapter, where we're going to be playing with operations on functions. And what a composition of function is it is one function made of or composed of one or more other functions. And so we're already familiar with four of function operations. And what that means is, let's take a look at two examples. When we have f of x equals x squared plus 1, and we have a g of x equals x plus 2. Function operations are, if I were to say, what is f plus g? This is function addition. That means I'm going to take f of x and add it to g of x. So I'm going to take x squared plus 1, and I'm going to add it to x plus 2 and get a result. For another operation, we have f minus g. So I'm going to take x squared plus 1, and I'm going to subtract g of x, which is x plus 2, and I'll get a resulting function. I also can do that with function multiplication, which is f times g, and I'll just basically FOIL these. I'll get f times g, or I could even do f divided by g, which will give me an x squared plus 1 divided by x plus 2, and I'll get an answer. So no matter what function operation we're doing, we're already familiar with these. What we're doing today is a composition. So we're going to be spiraling off into new material. So composing functions. And the way this is shown as either f, o, g. So it looks very similar to our f times g, but we notice that our circle is going to be open. Or we can have f of g of x. And they both mean exactly the same thing. I'm taking my g of x and I'm plugging it into my f of x. I'm taking my g of x and I'm plugging it into my f of x. So let's see what that would look like. Well, remember with our f of x and our g of x. So let's write that down again. F of x was x squared plus 1, and g of x was x plus 2. Well, if I'm taking g of x and plugging it into f of x, I'm going to write that as f of, I'm plugging in my g of x. So that means my g of x is plugged into f. And I'm going to write out my f of x. Instead of writing my x squared, I'm going to leave a space. And what do I plug in for x? I'm going to plug in my g of x. And what does g of x represent? X plus 2. So this is going to be x plus 2 squared plus 1. And I'll work that out till I get an answer. And if I do that, I'd have to FOIL this, which would give me x squared plus 2x plus 2x plus 4 plus 1. I'm going to combine like terms. I get an x squared plus 4x plus 5. And that is what f of g of x would be equal to, is that. Let's take a look at a few examples. So let's take a look at our examples, and let's write down four different functions. Let's write down an f of x, as being x squared minus 9. And just to allow this a little more ease of access, let's give a g of x is equal to 1/2 x plus 5. Let's take a j of x as an x minus 7. And let's take an h of x as a negative 2x plus 6. And so you can see we've drawn them in 4 different colors because when we start plugging them into each other, it's easier to keep track of this way. So you do however does best on your paper. We're going to do this here. So our first example is going to be, let's plug in h of g of x. Or another way to write it would be h of g, which means I'm taking g and I'm plugging it into h, or I'm taking my g of x and I'm plugging it into h of x. Either way, these are the same question, h of g of x or h of g. So we know our starting equation is going to be h of x. So I'm going to write out the h of x equation. So h of x is equal to negative 2x plus 6. And what am I plugging into h of x? G of x. So I'm going to say h of, I'm going to leave a space for when I plug in my g of x. Okay. And now what represents g of x? Well, 1/2 x plus 5. So let's expand that a little further. So that's going to be h of one half x plus 5. And let's see where this takes us. So now I'm just going to simplify what is this expression when I plug g of x into h of x. So I know I'm going to distribute this 2, which is going to give me a negative x minus 2/5 x. I'm not going to distribute all the way over here, so plus 6. That x doesn't actually exist. So it's negative x minus 2/5 plus 6, which means that I can combine these two terms, but I need the 6 to be a fifth. So if I cut each of these 6 into fifths, that will be 30/5. So negative 2 plus 30 gives me positive 28/5. And that is what h of g of x is equal to, is negative x plus 28/5. So let's take a look at a second example. Second example that we're going to do is we're going to do f of j of x. Or another way to write it would be f of j. Probably should have picked something other than a j and a g, but we'll work with that. So our starting function is f, or f of x. So we're going to write down what f of x is equal to. And our f of x is equal to x squared minus 9. Now what are we plugging into f of x? We're plugging in the j of x. So let's give it some space. And let's plug in our j of x. And now what represents j of x? X minus 7. So let's replace this j of x with an x minus 7. And so we get an x minus 7. And so at this point, we do what we did over here. We've plugged in j of x into f of x. We've plugged j into f. Now all we need to do is simplify it. So I have a squared, so I'm going to have to FOIL this. So that's going to give x squared minus 7x minus 7x plus 49 minus 9. So that's going to be combined like terms, combine like terms. That's going to give me an x squared minus 14x plus 58. And that is what f of j of x would look like. And so that's all a composition of function is, when you plug one into the other. Now, another way that you're probably going to see these questions asked is, instead of plugging in a generic x, why don't we plug in something like this? So for our third example, we're going to plug in f of g of 8. And so you'll notice that this is a little different. We're not plugging in just an x, we're plugging in an 8. So what we could do is we could plug in g of x into our f of x. I could take this and plug it into my f of x, simplify it, and then plug in my 8. But there's an easier way to do it. So let's write out the two examples that we had. So my f of x is equal to x squared minus 9. And my g of x is equal to 1/2 x plus 5. And we remember that what are we plugging into g of x? Well, an 8. So let's see what that would be. When I plug in an 8 into my g of x, I get that equal to 4 plus 5. I get this equal to 9. So g of 8 is equal to 9. So when I say f of g of 8, I'm actually saying f of 9. So I'm going to plug in to my f of x, my g, our g of 8, and we said our g of 8 is equal to 9. So it's actually f of 9. There's a square there. And so let's plug that in and see what we get. I'm going to plug in 9 squared is 81. It's going to give me a 72. So f of g of 8 is equal to 72. That's simply because we found out what g of 8 was, and we plugged that into f. Let's do one more like that. So our last example is f of j of 3. And so we know our f of x is equal to x squared minus 9. And we know our j of 3, well, I know, again, I should have picked a different letter, but j of x is equal to x minus 7. So I'm going to plug in a j of 3. And see what we get. So if I plug in a j of 3, I get a -4. So j of 3 is -4. So what actually are we plugging into f of x? We're plugging in -4. So let's see how this equation works itself out. So I get a -4. So my -4 squared is 16, which gives me a 7. So f of j of 3 is equal to 7. So there you have it. You have two different ways to do it. You can either plug in the generic equation and simplify, and if there was a number for x, you could plug that in at the very end. Or a faster way to do it, if you're just plugging in a number, is to plug it into this inside equation, take that answer, plug it into the outside equation. And so that's it for 9.1, composition of functions. This is a bit piece. Later on, it will be added into the inverse functions chapter, which you saw earlier on the semester. All we did was we took the value of one function, let's say f of x, we plugged it into another function, let's call g of x, into its variable. Now, we only did this with two functions, but realize you can do this many, many, many times, kind of like Russian stacking dolls. You can plug a function into a function, take that, plug it into a third function, take that answer, plug it into a fourth function, and so on and so forth. As many times as you want to do that, you're able to. But all we're going to be doing in this course is plugging one function into a second function and seeing what the new answer is. So if you have any questions over this, let me know.